We're going to take a look at scientific notation and in what cases we might be using that in class. So when you look at a number, it can be written in standard notation or scientific notation. So if it's standard notation, the entire number is going to be written out. And we can see in this example that the number represented here is a really large number. It's got lots of zeros. And if we're using that kind of data or we're using that to represent a model or something like that, then that number is just not going to be making sense for us to be able to use that in comparing any kind of data. So we're going to put that into scientific notation. In order to do that, we're going to be looking at a number like this where you have the first couple of non-zero numbers, and it's going to be multiplied by a power of 10. So in this example, it's times 10 to the 23rd, and the 23 represents the 23 spaces that the decimal had to move in order to get to the first number that was a non-zero number. Here's one other example. So this number, again, a really large number. It's not looking at the millions or the billions. It's the trillions place. So it's 2,300,000,000,000. And so when we look at this number, it's a really large number. So we need to represent that not in standard notation, but in scientific notation. So we're going to put 2.3, and that's our first couple of digits that we have there, times a power of 10. So this is 10 to the 12th power. And literally that's saying that we have 2.3 times 10 to the 12th, which would be written out as 2.3 times 10 times 10 times 10 times 10, 12 times. So it's literally showing us that that number 2.3 is multiplied by 10, 12 times. So when you look at a number that is written in scientific notation, all numbers in scientific notation are going to have three parts. So they're going to have a coefficient, and that is our number that's represented here. And it's going to be a number that is greater than 1, and it could even be just 1.1 or 1.02. So it's going to be greater than 1, and it's also going to be less than 10. So it's going to fall in that range of 1 to 10. It's going to have a multiplication sign, and then it's going to have a power of 10. So it's going to have this base of 10 with an exponent. So in this case, we have a -3 as our exponent. So this is the form that you're going to see numbers written in scientific notation. So when we convert a number from standard form to scientific notation, we're going to be moving the decimal point. So in this top example, the decimal point would be right here on the end, and we need that number to be a much smaller number than what it is currently. And so we're going to look for our first number that is a non-zero digit. And so we're going to move that decimal all the way down here. Here's our 1. So we're going to put 1, and there's our new place for the decimal. In this example, our decimal place was right here, 0 point, and we need to look for our first non-zero number. So we're going to move all the way down here to the 4, and so our decimal point is now going to be right there. So our next step is we're going to look at any zeros that we have. And if the zeros are between some other numbers that are non-zeros, then we need to keep those. But we're going to look for the zeros that are insignificant, the ones that are either at the very end or the very beginning of the number. So in this case, we have a handful of zeros right here. So we're going to delete those. And same case for this bottom example, a bunch of zeros at the beginning. So we're also going to strike through those. So that is going to help us to get to our times 10, and the amount of places that our decimal point had to move is what we're going to be counting next. So we're going to look for how many places our decimal moved from the original location. And that's going to help us to find our exponent for our power of 10. So if you look at this example on the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that particular decimal point moved from the location at the right to the left 13 places. Same example, same method. With this one, it started out with a decimal point here, and it moved 1, 2, 3, 4, 5 places to get to this first non-zero digit. So that 5 is very important, and the 13 is important as well, because that's going to become our exponent. So if you look at this number, originally this was a really large number. And in order for us to get the decimal from being here on the end, on the right, to the left, all the way over here, we moved that decimal point 13 places to the left. And for this example, we moved our decimal point to the right. So it was moved 5 places, but it was moved to the right. And since this number was a very small number, it had our decimal originally right here, that's going to be a negative. So if you're moving the decimal point to the left, it's going to be positive. And if you're moving the decimal point from the left to the right, then that's going to be a negative number. And that number will become our exponent. So how are we going to write this out? So here's another example, 1.109025. So this is just like what we moved our decimal point from the right to the left, our first non-zero number that we have here. So we've moved that decimal point 13 places. So how we write that out is we take our number, and remember, we've gotten rid of all these insignificant zeros, all those zeros at the end. And so now what we have left is all these, for the most part, non-zero digits, or the zeros that were contained within those numbers. And that's going to be times 10, and it's going to be to the 13th power because we moved the decimal point 13 places. Now this one is positive, but we don't have to put the positive because it's understood that it's positive unless you write a negative. So in our other example here for this number that was much smaller, we have moved the decimal point from the left to the right 5 places. And since it was a much smaller number, that decimal point was moved to the right. And so that is a negative 5. And how we would write that is 4.205 times 10 to the negative 5th power. And you can notice on these that they were rounded just a little bit. So the number, if it is significant figures that you need to be able to keep all of these numbers, then you'll be instructed to do so. But in general, it's okay to just round it so that you have one place past the decimal point. So when we're shifting from scientific notation to standard form, we're going to be basically doing the reverse. So we're going to be moving the decimal point the same number of spaces as the exponent. So in this case, we have 2 times 10 to the 9th power. So that means that our 2 right here has a decimal point right behind that. And so we're going to move that decimal point 9 places. So we're going from right here to 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the decimal point is going to be right here. So that has basically extended our number from scientific notation to standard notation. And in this example, we have 4.6 times 10 to the 14th power. So we're going to take our 4.6 and we need to move that decimal point to, since it's minus, we need to move that so that it reflects that much smaller number. So that decimal point is going to be moving to the left. So we're going to go from the decimal point being right here after the 4, and we're going to move that 14 times until we get this big long number, which is a super tiny number. Any spaces in which you've moved the decimal point to, any spaces that have been brought up as a result of that are going to be filled in with zeros. So there's no other number that's going to be placed here as we're moving minus 14 spaces to the left, but we're just going to fill that in with zeros. So here's one last example, 5.2081 times 10 to the 12th power. So we're going to have our decimal point right here after the 5. So we're going to be moving that decimal point, since it's a positive number. That means we're going to be expanding that scientific notation and making it standard form, and that will be reflective of the larger number. So we're moving that decimal point to the right. So we're going to be moving that 12 times. So the decimal point starts here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.